All right, everyone, so we're continuing on from trigonometry, and while we've been looking at our trig, we've usually just been looking at triangles that are right triangles, meaning one of their angles is 90 degrees. However, we can also use trig to find the angles and leg sides for triangles that aren't right triangles. So now we're going to take a look at that. And the first way that we do that is by using this law of sines. And the law of sines shows the proportional relationship between angles and their opposite sides. Very similar to when we were looking at comparing similar triangles, and we would set up those ratios. This is going to be very similar to that because each triangle is actually its own proportional relationship. And now we can use that to find those missing lengths and angle measures for any triangle. Doesn't matter what triangle it is, we can use this for any triangle. So we're going to use the law of sines. And the law of sines is something very particular. I'm going to first label parts of this triangle so that when I write out the law, we can follow it a little bit more easily. So I'm going to make side A orange, and its corresponding angle is angle A. So I'm going to make both of those orange. For side B, I'm going to make it green, and its corresponding angle is B. I'm going to make that green as well. Last color, blue, for side C, and its corresponding angle, C. So when I say corresponding, we mean the opposite angles, the angle that does not use that side at all to make it the opposite side. So given our triangle ABC, we want to be able to write our law of sines. And since it is a proportional relationship, we can write this as the sine of A over A is equal to the sine of B over B, and that's equal to the sine of C over C. So we're taking that trig function of sine and dividing it by its opposite side in order to get one of these other ratios. These are all going to be equivalent proportional relationships, and so we can use these in any way to find anything that we're missing from our triangle. Now, one thing that we can do is we can use, if I have angle A and side A, but let's say that I have side C and I want to find angle C, well, we don't need to have this B in here. We can use just two parts of the law in order to write out our solution. So let's go through an example. This first problem, we have the side 12, which is opposite of this angle 35. And then we have this angle 71, which is opposite of this side x. So we're not given our other side here. We're not given this other side or the other angle. So we're not trying to find that. We just want to solve for x. And since we're trying to solve for x, we know that since I'm using blue, I'm going to keep using blue. X would go on the bottom, and sine of 71 would go on top. Now we know that that is going to be equal to my other relationship here between the sine of 35 and the side 12. So we can go ahead and solve this just like we would any other trigonometry problem. First thing I want to do though is I want to get x so it's not on the bottom anymore. So I'm going to multiply both sides by x, multiply by x. And so now I would have this x sine 35 over 12 equals sine of 71. Well, I don't like that this 12 is on the bottom, so I'm going to multiply both sides by 12. So we have x sine of 35 equals 12 sine of 71. Well, we said that our trig functions are just a function, this would just give me a number. So I can divide both sides by sine of 35. And so now I have x equals 12 sine of 71 divided by sine of 35. So plug that in your calculator. What do you get? Well, if I take my calculator, I'm going to type it in just as it appears, 12 sine 71 divided by sine 35. I got 19.78, and again, we're going to just round to the nearest tenth on this one. So I get x equals 19.8. Okay, let's try another one. Let's set up another ratio here. Let's do number 2. So for number 2, I have the angle 18, which is opposite of this side 5. And then I have this angle of 114, which is opposite of side x. So I'm going to go ahead and set up that ratio. I have x with 114, so I put sine of 114 divided by x equals, and then I have 18 opposite of 5, sine of 18 divided by 5. Now you could do this a little bit different than I did the last time. Like I said, our sine function is just a number, so instead of waiting to solve what that is afterwards, we can actually find that right now. I can take sine of 18 divided by 5, and I get 0.0618. And I'm going to go out a little farther with this decimal because I want to be as precise as I can be when I'm rounding that decimal. And now that's going to be equal to sine of 114 divided by x. Again, I want x by itself, but I don't like that it's on the bottom, so I'm going to multiply both sides by x. Sine of 114 equals 0.0618x. Dividing both sides by that 0.0618, you would get x equals, now the handy thing about your calculator is that you can actually use this last answer you got in your next step. You can do that by typing in, first I need sine 114, and I'm going to divide that by the answer I got last time. Now, if you look down here, your negative sign button has that ANS above it. That means we're going to use our answer from the last problem I put in my calculator. So to get that, I use that second function again, just like we did when we had our inverse trig functions. And so I get that that side would be equal to 14.8. Okay, so you can go ahead and give these other problems here a try. The rest of these are still all trying to find a missing side length. Next, we're going to try and solve some problems that have a missing angle. All right, so we want to take a look at problems 9 and 10 here for our next couple of examples, trying to find the angle of these triangles. So we have our angle 77, and it is opposite of the side 14. We were also given this side 9, and that's opposite of the angle we're trying to find, x. So I would write this as sine of x over 9 equals the sine 77 over 14. All right, so we want to get x by itself, so that means that I need to get this 9 out from the denominator. Multiply both sides by 9. So I have sine of x equals 9 sine of 77 over 14. Now, again, I could go ahead and just make this a number, or I can just keep going. I still want x by itself. And since our trig are all just functions, we can take the inverse of a function. And I have to do that to both sides. So now I have x equals sine inverse of this whole big thing, 9 sine of 77 divided by 14. And you can enter that in your calculator just as it appears. So if I take my calculator and I type in second to get the inverse of sine, and that's 9 times the sine of 77 divided by 14, I get 38.78, and rounding that I would get 38.8. So x equals 38.8 degrees. All right, let's go over number 10 as well. Number 10 gives us the angle 126, opposite side of 31. And we have side 15, which is opposite of our missing side x. Okay, so we want to be able to find this angle x. So we would have sine of x over 15 equals the ratio that we were given, sine of 126 over 31. And we want to solve for x. So again, multiply both sides by 15. We get sine of x equals 15 sine of 126 over 31. Now I'm going to take and solve this right side here first so that it's maybe less to put in my calculator all at one time. So 15 sine of 126 divided by 31. So we get sine of x equals 0.3914, let's just say 6. And so now I want to take the inverse sine of both sides to get x all by itself. Inverse of both sides. So I have x equals sine inverse of 0.39146. And again, I can use the answer I got last time in my calculator so that I don't have to use this number that I've been rounding with. So second sine inverse of second answer. I get x equals 23 point, we'll just round it up to 1. And that would be degrees. Now, this was the law of sines. Again, there's a few more examples here, so if you would like to have a little bit more practice, you can go ahead and solve these examples. I will be posting the completed notes page in our Schoology resources, so you can always take a look at those in our daily folder. Again, if you have any questions, please email me, come ask. I'm always willing to answer questions. See you next time.